My name is Conley King and I am from Hydro Weekly High School, and this is my final Principles of Engineering project. You had to pick from several different tasks if you want to complete one. I picked the bomb disposal robot. It's got to find a tennis ball in a 10x10 blue taped off square and find the tennis ball and dispose of it outside of the square. And it has to do it in under 2 minutes. And usually 90% of the time you'll find the ball. You never can guarantee things like this, but it does its best.
This is our elevator. It's pretty basic. It goes to 3 different floors, but it also has a safety feature so that if it waits long enough, if it's on a top floor, it goes down back to the bottom floor. So there it goes. And when it does that, it does flash periodically.
Hello, this is Grayson and David. We made a conveyor belt for a grocery store. So how it works is you just click this little red button right here, and the conveyor belt will start moving. You start placing objects on it. When you take it off, a number appears on the little pad of how many objects are running through this. You can stack as much objects as you want on it. It'll just keep on going up, and yeah, that's really it on it. It can't go off the sides or anything. We made it to where it doesn't. So, but yeah, that's pretty much the basis of it.
So I was asked to design a soccer goal with goal line technology, and if the ball was to pass the goal, this light right here would light up. Stay that way for 10 seconds. As demonstrated here, this light will light up for 10 seconds, and it will count the goal on the screen. Fortunately, we did have some issues with the coding part and the sensing part, and because one of the major constraints was if the goalkeeper would be detected if they crossed the line as well. So during this issue we ended up coming up with this little thing to simulate the coloring the goalkeeper would wear, a much darker color than the soccer ball. And fortunately, the sensor does not detect the goalkeeper at all, no matter how far, but it will continue to detect the ball. And probably the biggest issue we've had was with the sensors, because it would continuously detect skin tone and such. No, it's not. And that's it.
So this is our automated guidance vehicle, AGV, and our problem was it needs to drive back and forth in a straight line. So in order to solve this problem, dare I say, we created a program using these wheels where it can't turn because it's got front wheel, it's got all-wheel drive basically. So you hit this button on the inside where it carries all the supplies, and it'll drive forward until it detects an object within a foot of it. And then once it detects that object, it'll begin driving backwards until it detects another object within a foot of it. And then it'll stop and wait for another button click, or we would either just hit the kill switch and just completely stop the program. So that's our automated guidance vehicle.
My name is Grayson Ruckman. I'm from Hydro Weekly High School.
My name is Peyton Marley, and I'm from Hydro Weekly High School.
And this is our little robot arm that we made for an engineering project. It was actually kind of hard to build, actually, but we got it to work, and it's kind of cool. So it has 3 degrees of motion. It pivots here. The arm can move here. And then this moves. And then the arm also opens this little piece of thing. And the assignment was to make a robot arm that could pick stuff up. So for instance, you can grab this little bottle of glue and hold it and move it around. And then you can drop it. that's what it does.